Up until now, we added a new machine and material to the iMachining database. We also defined the CAM part, as well as the rough and finish machining of the outside contour. I even talked about the iMachining technology wizard in depth, and we experimented with some of the different settings. Now in this video, we're going to pick up where we left off previously. We'll put back the defaults and have the wizard automatically generate the cutting conditions. After we recalculate and save the operation, I'll point out the areas where the roughing tool will not physically fit. In such cases, you can remove the rest material using the iRest technology type prior to finishing. First, let's finish with our iRough operation definition. We already have the geometry and tool defined for the operation. Let's start by switching back to the Levels page. We should make sure that we have the correct pocket depth since we changed this in the previous video. Click the Pocket Depth button and pick on the lower face of the pocket to define the correct machining depth. Then click OK to accept the selection. Then move back to the Technology Wizard page. Choose Automatic for Step Down and turn the wizard back on using the button at the top right of the Operation dialog box. On the Technology page, take note that the default wall island offset is the usual 0.24 millimeters. On the link page, we'll see that the helical entry into the pocket will be performed at a ramping angle of 5 degrees. As I mentioned in the previous exercise, the ramping angle parameter is automatically set according to the machining level aggressiveness. Let's now calculate and simulate the results. Click Save and Calculate, and then click Simulate to open up the Simulation Control Panel. I want you to take a good look at the iMachining toolpath for a minute. So zoom into the pocket, set your desired speed, and click the play button. You'll see that the pocket is split into two areas, both of those areas containing a helical entry followed by the pocket roughing toolpath. Due to its size, the tool was unable to fit through these narrow spaces. So what should we do now? We cannot go straight to finishing, right? We first have to clear out this remaining material. So let's see what iMachining can do for us when we use the iRest technology type prior to using iFinish. Go ahead and exit the Simulation Control Panel and then click the Save and Copy button to create a copy of the current operation with all the same settings. Some of these settings, however, will have to change. First of all, click the Technology dropdown in the upper left corner and choose iRest from the list. Now, as you may have guessed, we'll want to use the Copy Geometry definition. You can take another look at it if you'd like by clicking the Show button. Exit will take you back to the Operation dialog box. Now move down to the Tool page. Since our previous roughing tool cannot fit in the tight corners or through the narrow spaces, we have to define a new tool. So click Select and then the Add Milling Tool button to start the tool definition. Select End Mill from the Milling Tools list. Leave just about all the given parameters, but change the number of flutes to 4. This tool will be perfect for not only our rest machining, but also our finishing. Now click Select to choose the tool for the operation and exit the Part Tool table. We can use the exact same milling levels definitions that were copied over from the iRough operation, and we can even use the default cutting conditions generated by the wizard based on a machining level aggressiveness of 6. Let's now spend a minute or two on the Technology page. First, I want you to switch to the iRest Data tab. Now, as I mentioned in the previous exercise, there are 3 important values needed for calculating rest material. They are previous tool diameter, previous wall offset, and previous fillet radius. When using the Save and Copy function, the previous parent operation is chosen by default, and the fields are automatically filled with the associated values. In the instance the previous operation is not an iMachining operation, these values may also be entered manually by choosing User Defined from the drop-down list. You'll notice that the fields are now open to be edited. For the purpose of this exercise, we should just leave the default selection of iRough Contour 1. Now, it's important for you to know that the wall island offset for rest material must be greater than 0 but less than the previous wall offset. We can compare those values under the iRest Data and Technology tabs. So here we have a previous wall offset of 0.24 millimeters and a current wall offset of 0.12 millimeters. Let's now click Save and Calculate to add this iRest operation to the CAM tree and calculate the iMachining toolpath. Then, click Simulate. When the simulation control panel opens, click the Play button. The tool performs the rest machining and works around the walls, islands, in the corners, and through the narrow spaces. Let's say that for this operation, we want to limit the machining of rest material to only the corners and not the walls of the pocket. iMachining can do that for us. So exit the simulation control panel, which will take us back to the technology page. In the rest material area, select the corners only checkbox. Using this option could help us save on the cycle time for this operation. Though, take note that the wall island offset is now inherited from the previous operation, and the input field text box is locked from being edited. Let's calculate and simulate the new results. So click Save and Calculate, and then click Simulate. When the simulation control panel appears, click the Play button. This time, we can see the tool working in not just the corners, but the narrow areas as well. You can see here that we even reduced the cycle time by almost half. Now, we can perform the finishing of the walls and islands of the pocket using the iFinish technology type. First, exit the simulation control panel, and then again click the Save and Copy button. A copy of the current operation will be created and will automatically be opened. Change the technology type to iFinish. In this case, this is all we have to do. We will use the copy geometry, tool, and levels definitions from the previous iRest operation. We can also use the default cutting conditions generated by the wizard. Switch to the technology page and then move to the iRest Data tab first. You'll see that the previous iRest operation is selected as the parent operation by default, and the fields are automatically filled with the 3 important values needed for calculating rest material. Now, switch back to the Technology tab. We can see that the wall island offset automatically defaults to 0. We are also presented with some toolpath optimization strategies for finishing. We will only need to finish the walls and not the floor. In this case, we can select either total depth or each step down in the wall finish area, since these depths are the same. For this example, let's also select the Spring Pass checkbox. This option will perform a secondary pass along the walls in addition to the primary finish pass. It aids in offsetting tool deflection to ensure that parts are finished more accurately and dimensionally correct. Now, since this operation will remove the original 0.24 millimeter allowance, it may be a good idea to use this option. Finally, we can click Save and Calculate to add this iFinish operation to the CAM tree and calculate the iMachining toolpath. Then, click Simulate to open up the simulation control panel. We'll use the host CAD mode, just like we've been doing all along. I would first slow the simulation speed down, and then click the Play button. The tool first works in the corners to remove the 0.24 millimeter allowance. It then performs a primary finish pass around the walls and islands, followed by the final spring pass. Let's now exit the simulation control panel. Now, I would like to quickly talk with you about synchronization. It is important to know that rest machining pulls data from a previous parent operation, as shown before in the iRest Data tab of the Technology page. If one of these 3 important values changes, the data will update, but the latter operations will need to be recalculated. So, for example, go ahead and exit the iMachining operation dialog box And let's edit our previous iRough operation. So double-click iRough Contour 1 in the InventorCAM Manager to open the operation. Switch to the Technology page and change the wall island offset to 0.12 millimeters. After clicking Save and Calculate, we can see that our iRest operation is no longer calculated, as shown by the asterisk in the InventorCAM Manager. We'll need to first exit our current iRough operation. Then double-click iRest Contour 1 in the InventorCAM Manager to open the operation. If you switch to the Technology page, you'll see that the wall island offset parameter and iRest data have been updated. We can click Save and Calculate to recalculate the operation. However, you'll see that our iFinish operation is now no longer calculated. So once again, exit the current iRest operation. The iFinish operation we can recalculate from the CAM Manager. So to do that, right-click iFinish Contour 1 and choose the Calculate command to recalculate the operation with updated iRest data. I'll go ahead and end Part 4 right here. So there you have it. We just defined the machining of the pocket using the iRough, iRest, and iFinish technology types in iMachining. Now, in instances where you have pockets with island configurations that prevent the roughing tool from being able to fit in some areas, don't worry. You can easily use the iRest technology type prior to finishing. You can also quickly use the Save and Copy function to simplify your selections and to automatically define the iRest data from one operation to the next. Now, join me for the last part in this series where I'd like to talk with you about the tool definition and what parameters specifically affect iMachining and the wizard.